All right, welcome back. The last transformation, which is symmetry, talking about three different types of symmetry. The most obvious, the third grader version of symmetry is line symmetry. All right, a figure has line symmetry if the figure can be mapped onto itself by reflection in a line. Think of a mirror image. This is what we all know, right? That if I think about this shape and I draw a line that looks like this, if I fold it, it would land right on top of itself, right? Perfect. That's called line symmetry. I think that we have done line symmetry before. I think that we get line symmetry. So, just for a second, let's look at a couple different letters. How about this? The letter A. Do you think that this has line symmetry?
Yeah.
Yeah. And how are you going to draw the line? Draw it up and down, right? Now let's draw the letter B. The problem with this is there's a couple different ways to draw this. So exactly the way that I drew it here, does this have line symmetry? I would say no. I don't see a way that we can draw this, flip this, and make it symmetrical. All right. What about the letter C? And again, I'm trying my best to draw it. Does this have line symmetry? Now, if I do it up and down, definitely not, right? Because this side would have a big gap here, and this side would not. But what if I cut it sideways like this? Yeah. So when it comes to these, we got to look for a line that's going to fold it like this, a line that's going to fold it like this, and we even need to look out for a diagonal line that would work. Okay? So line symmetry, I think we got it. Now, point symmetry for me is the hardest one. This is the one that I, even as a teacher, I like slow down and I think about point symmetry. All right, if you want to put a star, put a star. Point symmetry, if the figure can be mapped onto itself by rotating the figure 180 degrees about a center point. Now that one's a little tough, okay?
Yeah, so like, if you were to rotate that, say twice, right? Like, it'll match up with how it looks on the top.
So you got to be able to kind of take the paper, look at the paper upside down, and it's got to still be the exact same shape, okay? I know that maybe doesn't sound too crazy, but, you know, it can be a little bit tricky, okay?
This on the graph, say you got four quadrants and stuff, and like a 90, you go to like one side, kind of, not, like, it'll
I
be,
got you.
like, it don't matter which way you turn it, but like, it'll be where you, like, how many times you turn it.
So basically, I hear what you're saying. If the end was like this, right? But when we're doing this, we're imagining that the point is right in the middle of the end. You see what I'm saying? And so when we spin this in around like this, we don't really need to think about the quadrants, right? Just spin that shape around, better look exactly the same. Okay? So that's why it's called point symmetry, because it's like there's a point in the middle that we do a rotate with.
So like, you're not cutting it, like,
No lines, no lines at all. Just spin it around. That's all that matters. And then we got rotational symmetry. If the figure can be mapped onto itself by rotating the figure less than 360. So basically, like, as you rotate it around, obviously when you go 360, you're gonna be back where you started. But sometime before that, does it end up working out? So, and I could have been a little better prepared for this. We had a nice picture of a sun, right? A circle. And of course, my drawing is not going to be exactly perfect, but I'm doing my best. So as I rotate it, now it looks different, same, right? And so because of this, it has rotational symmetry. Before I got all the way around, I got to another part that looked the same, okay? Even though it's like different, same, different, same. I'm just looking for one time before I get all the way around. Now, Ms. Bass, that means that everything that has point symmetry will also have rotational symmetry. Is that making sense? I got you. So obviously, if 180 degrees works and this says anything less than 160 works, that means that everything with point symmetry is also going to have rotational symmetry. Sorry to put you on the spot there. So here we go. Let's look at this square. And it's not a square at all, it's a hexagon. I don't know what I'm talking about. We got a hexagon. Can you draw a line here that's going to make the shape fold perfectly onto itself? Yeah. In fact, there are a lot, like 6 or something, right? I mean, I could draw a line that looked like this, that would fold that shape perfectly and it would land right on top of itself. I could also draw a line that looked like this. And even that, I could fold perfectly, nice, right onto itself. I really don't care. I just need to know if there's one. And I agree with you. Yes, there's at least one that has line symmetry. Kazoo time. Then we got point symmetry, which means if I look at this paper completely upside down, does it look exactly the same as it used to look? Yes. So I agree that it's got point symmetry. And the way that this works, if you got point symmetry, you're always going to have rotational, because rotation says, can you spin it around and get to where you used to be? And we just saw, yeah, if you do it 180, it's going to work. And so this nice, perfect, we would call it a regular hexagon. This regular hexagon, check, check, check. It's got all 3 different types. Let's move on to number 2. And as you can see, these are going to start from nice, regular polygons, and we're going to eventually be talking about some crazy lightning bolt type shenanigans. So here we go. Triangle. Can you draw a line to fold this triangle in half? Yeah, there's a couple. I'd say there's probably 3 different ones, right? This one works pretty good. This one works pretty good. This one works pretty good. That's plenty enough, right? Line, check. Point symmetry. If this paper goes upside down, does it look exactly the same? Now, obviously, it's still a triangle, but the triangle's upside down now. So this is going to be a fail, right? Point symmetry, no good. Now, that doesn't mean that rotational symmetry has failed, but we can't just automatically give it a check. As we spin this around, I know 180 doesn't work, but is there some other time that it gets back to a normal triangle? I would say right there, this looks like our original shape, okay? So yeah, complete 180, not working. But if we do a little 1/3 turn, for you math people, that might be 120 degrees, it does look pretty good. Rotational, I'm liking that. All right, let's check out number 3. Now, so far, line symmetry, right? I mean, we love line symmetry. Line symmetry is super easy. We like that. What do you think about number 3? Can you draw a line and fold it up and make it work? So let me zoom out here real quick. Let me draw a nice picture for us. We got this shape. It doesn't look like that crazy of a shape. What was your idea, bro? Up and down or diagonal? You want this way or this way?
From that to that.
This like this? Okay. If I draw, if I think about this line, if I fold it onto itself, and this is why I kind of like the Sharpie, it needs to basically line up perfectly. And you see how we have some, I mean, it might be a little hard to see, but you see how we have some issues here. Like this corner, there's no shape right here where this corner ends up.
That's what I'm saying.
I don't think that this line works. You want to try another line?
Nah, it ain't work.
It's not gonna work. As easy as this shape looks, we might as well just try one more, right? If I think about this line here, if I fold it, you see how we're having issues here. This corner, there's no shape underneath there. We got a problem. Okay, so this shape has a failed line symmetry. Now that doesn't mean that we just give up on the other ones, okay? Point symmetry, when you rotate it upside down, what do you think?
Nah, this shit's stacking on each other. It's stacking.
We're doing this one?
The way you folding it just straight up and down. You're not folding it with a curve.
All right, I'll do my best.
That's what I'm saying.
Let me try another time. Let me try another time. Here,
When I fold it, it's folding on top of each other.
I got you. So let's be fair. Maybe my shape wasn't right. Okay, I'm gonna trace it. Okay, I'll make it extra dark to make sure it's gonna bleed through. And you're talking about this line right here.
From that corner to the other corner.
I think it doesn't quite perfectly line up. It is close. In order for what you're saying to work, these would have to be the same length, right? So like this length right here, if we call this L, this long one over here is a little bit more than L. And so that's not gonna work because these lengths are different. If we had a shape that looked like this, but all the sides were the same size, I agree with you, then it would work. But this one in particular is close, but I don't think that this one works. Point symmetry, I think we did that one. Rotate it upside down, it works. And if you can rotate it upside down, then rotational is gonna work as well. Check, check. So we've seen a lot of different varieties so far. All three of them can work. Only point can be a fail. Only line can be a fail, right? We've seen a lot of variety here. What do you think about number 4? We got a nice right triangle. I agree. Line, I think, is going to be a fail, right? I really can't see a way that I can draw a line to make it fold right onto itself. Some of us are going to be really good at this, and visually, we're just going to be able to see this happen. And some of us, it might take a little bit of a time, and that's okay, right? We don't all have to instantly know how to do this stuff. As far as point symmetry, if I go upside down, my right is in the bottom left, but now it's in the top right. So this is not the same. I'm saying no for a point symmetry. And maybe the full 180 doesn't work, but does it work before that? No. This is different. Now the right triangle, now it's in the bottom right. This is 180. I know this doesn't work. Now it's in the top left. No. I think that this is a fail. So I think that this is a no symmetry shape, right? Your shapes don't have to have symmetry. What'd you say? All right, so I'm gonna give you guys a second, all right, to think about 5 and 6. Does it look like point? Does it look like rotational? It could be all of them. It could be none of them. I'll give you guys maybe another 60 seconds. Just try 5 and 6. Again, we got that test coming up tomorrow. All right, number 5. So if we're working with number 5, what did you think? Did you find any line symmetries? I think yes. I think this one's got quite a few different line symmetries, maybe 10 of them, right? I think if we go through any of the points, it's gonna work. That one's gonna. I think I said. I don't know if I said 10 or 5. But I think it's 5. Go through that point is gonna work. Go through that point is gonna work. Go through that point. These are all looking pretty good. Okay. Definitely line symmetry is looking good. What about point symmetry? If I go upside down, how's this star looking? It's looking different, okay? Because instead of being a 1 point on the top, I'm gonna have a 1 point on the bottom. That's not gonna look very good. And then what about rotational? I know that the full 180 doesn't work, but as I rotate, that looks good, right? That is a solid star from where we started. As I rotate, that looks good. That looks good. So I agree, rotational as well. I'm working with 2 out of the 3. Any issues with number 5? Any disagreements? We're good? Okay, number 6 is definitely funkier. No doubt about that. For number 6, did you find any line symmetries? Did we say, everybody say no, or somebody say yes, or I couldn't? All right, so what do you got for yes? Are you going straight up and down, straight side to side? Diagonal? Are you going this way or this way?
That way, the other way.
This way?
Yeah.
Okay. Let's see. Okay. If I fold it diagonally here, it definitely is looking pretty close. Make sure I get it right. But it doesn't actually work perfect.
Shows like at it on, like not flat, not with the back flat to the paper. Like turn it. No, in the middle. Or turn it more to the middle. Now try to pull it.
Like this?
Yeah.
Oh, I see what you're saying. So when you do it like this, this is a gap right here, right? That's a little gap, and that gap is not that's being folded onto the line there. It's not quite a perfect lineup. I need to get some of that thinner paper. Prove it to you. Maybe I could do it a little bigger. Let me see. All right. If I do it a little bigger, maybe we can see a little bit better. If I fold it diagonally, it does. We're like, all right, nice. You know, I can see that this corner is lining up with this corner, so that is nice. But then, like right here, you can see that the outside is okay, but the spike just doesn't quite line up. There's a little bit of a gap right here. There should be a piece there. There should be a piece there. And underneath, there's no piece here, and there's no piece here. So, you know, there should not be a piece here. There should not be a piece here. Here's what I'll say about the line symmetry, all right? If you feel like you're having to really cook and to really work hard to like, oh man, he's onto something there, that's crazy, it's probably not it, all right? As far as the line symmetry goes, just think simple, all right? Could a third grader notice that these are the same? It is super close, and you're not crazy for thinking that these are close. You're almost like trying too hard. This is not a line symmetry. It's super close, like we said. There's just a couple gaps that don't line up quite right when you do this one. Point symmetry, completely upside down. I see, you know, we got a top right, bottom left. We got a top right, bottom left. I think the point symmetry looks pretty good, which means rotational is guaranteed to be pretty good. So we've got a couple different shapes. If you look on the back, it's just a whole bunch of different shapes. All right. I don't necessarily want to torture you with 20 examples of going through all of these, but at the same time, these questions are ones where like we really want to be getting the symmetry questions right. All right. When it has to do with folding and spinning, like this stuff's maybe a little too easy. We definitely want to get these right. I've got a few that, you know, we're going to skip and a few that we're going to do. So let's look at the lightning bolt. Do you think the lightning bolt has any line symmetry?
No.
No, I agree with you. The lightning bolt, no good, not going to work. What about the lightning bolt point symmetry if I spin it upside down?
No.
That's going to be no good, right? I see that my lightning is in that bottom right corner, and then when I spin this over, now it's up in the top left. So this is not good on point. And as far as rotational goes, lightning bolt is now going up, it's not going to work for rotational either. The lightning bolt is going to be a none. Any questions on the lightning bolt? All right. I like number 9 a lot too. Okay. I think it's pretty clear that this is going to have some nice rotational setups, right? Because as we spin this, it's like a little pinwheel. You know what I'm saying? As we spin this, at the start, we got this nice right angle at the top. We get here. This is like so annoying to do. We got this nice right angle, and again, looks the same over here. We got this nice right angle at the top. We got this nice, like, rotationally, it works good. I think point-wise, it looks good as well. Now, line-wise, when it comes to line symmetry, you know, maybe it could work along this, but if I fold that, I don't think it's gonna, you know, is this side the mirror of this side? No, I don't think so, right? And obviously this is gonna be the same, it's gonna have the same issue. So what about diagonally? If I think about diagonally, that has a triangle up here with one sticking out on the bottom. This has a triangle down here with one sticking out on the top. This is also no good, right? Even if I fold this over, like this triangle right here is gonna land over here, and that's not gonna match up.
Oh, I thought it was gonna land over top of each other. It looked like.
I got you. That we can't. It kind of looks like it has line symmetry, but it doesn't. Okay. What about the letter R, right? We like the letter R. Does it have line symmetry? I don't think so, right? That, not gonna work. We got the loop part and the sticks part. This, not gonna work. We got the straight part and we got the bumpy part, right? I mean, the line symmetry is just not gonna work. What about point symmetry? Upside down, is that the same thing? The upside down R? Like, is that still a letter R? Like, maybe if you're in Russia or something, you know? They got those crazy R's in Russia. I don't know, terrible joke. And then we got rotational. Is there some other angle that works? No, right? The R has no symmetry to it whatsoever. All right, I want to look at this number 12 really quick. And this is one that's like almost like a trick question in a way. It's a nice normal shape. Okay, does it have line symmetry? Definitely, right? Boom. We got this nice line symmetry right down the middle. It folds like a book. Perfect. Easy, easy, easy. Now let's think about point symmetry. Upside down, is this the same exact shape? It's very close. But because that this number 12 has sides that aren't all the same, we kind of run into that problem, all right? Because if you look here, we've got the long sides on the top. That's a long side and a long side. And these are the shorter sides on the bottom. And when we rotate this, now it's different. Now we got the long sides on the bottom, the short sides on the top. So point symmetry, I don't think so. Point symmetry is not working. And rotationally, we have to have the long sides on top. And when we turn it, the long sides are left, doesn't work. When we turn it, the long sides are on bottom, doesn't work. When we turn it, the long sides are on the right, doesn't work. And then we get back to normal, which means we failed rotational as well. So that shape, it does look like it would maybe have rotational, but it's just a little wonky. The rest of these shapes, you know, I mean, whatever. Maybe it's worth it talking about the Z. Does the Z have line symmetry? If I show you a big letter Z, and of course the letter Z is just like the letter N as well, but if I turn this upside down, does it still look like a Z? Yes. Sounds good. That means it has rotational, that means it has point symmetry. But what about line symmetry? If I fold it side to side, this is not working because my Z, I can see this piece here is kind of missing. So that's not working. And maybe you think, oh, well, maybe I could fold it diagonally along this line right here, and it still doesn't quite work because here's my line. Now this piece is missing. So the Z has no line symmetry. Okay, that is symmetry. There's 3 different types. None of it is rocket science. You just got to take your time. If you feel like, ooh, I'm super smart and this line symmetry, some of my classmates aren't going to figure this out. You might be working too hard. Like you might be digging too deep about the line symmetry. The line symmetry it should always feel like, oh yeah, everybody in class is going to get this because it's pretty obvious. All right. There's our notes on symmetry. Of course, there's extra problems here. If you want to look at those, you can go for it. All right.